Inverse of quadratic function. So this is the third one in our series of understanding inverse on quadratic function. We start with the parent function. We did a transform function where we moved left by 1 unit. And this time we have a transformation which involves stretches and compressions and also translations. So let's try to see how to find inverse of such a quadratic transform function. So the first part of this question is determine inverse of the function y equals to 2 plus 3 times x plus 1 whole square. Now I've already given you a graph here to appreciate that this is how the function is going to look like. Vertex is at minus 1 x value, y value of 2. That is minus 1, right? And x value of 2. It opens upward with steps of 3. Do you see that? Instead of 1, 3, 5, it is 3, 9, 15. So the first step is 1, 2, 3, correct? So that is how this graph is, right? So let's find the inverse of this function. Let me do it graphically this time first, right? So when we want to draw the graph of inverse graphically, what you need to do is to reflect the graph on the line x equals to y or y equals to x, right? So that is my line which is y equals to x, right? So let's start reflecting it. So let me do the first one by one each half. So I'm using red ink for the right half. So let's start from here, which is minus 1, 2. And when you do graphically, you can reflect it like one diagonal and half diagonal. Half and 1, so we get this point. Do you see? So that is the vertex. And the next point, good point for us, is 0 and 5. So we can do one diagonal, two diagonal, and a half. Half, 1, and 2. So we get that point, which is 5 and 0, right? So we get two halves like this. We can join them and get the upper half of our transform function. Now let's see the lower half or the left side of the parabola. So the left side of the parabola, first point is the vertex itself, which is same, and then we have minus 2 and 5. Diagonally, let's go reflecting it on the line y equals to x. We get 1, 2, 3 and a half. So we get half, 1, 2 and 3. So that is the point, right? So we can join this. Well, that is it. So that becomes inverse of the function, correct? Now let's find out the equation of this algebraically also, right? So to find inverse, we need to swap x and y. So let's do inverse first. That is, we swap x and y values, right? And then solve for y. So we have the equation which is y equals to 2 plus 3 x plus 1 whole square. So let's swap. We get x equals to 2 plus 3 y plus 1 whole square. And now let's solve for y. So we get x minus 2 equals to 3 times y plus 1 whole square. It becomes x minus 2 divided by 3 equals to y plus 1 whole square. And we can do square root with plus and minus. So we get x minus 2 over 3 equals to y plus 1. And from here we can write y as equals to minus 1 plus and minus square root of x minus 2 over 3 whole square, right? So that becomes the inverse of our function, right? So we have inverse of the function here, and let me write down clearly here, that is y inverse is equal to minus 1 plus and minus square root of x minus 2 over 3 whole square, correct? Now since we have plus and minus, it is not a function, correct? So that's very clear. So this is not a function. Now let's look into the second half of the question, which is explain how you can restrict the function to ensure that its inverse is also a function. So the technique which we've learned is restrict domain. So that is what we have, right? So we have to restrict domain. So how can we restrict it? We'll restrict it because we know that the graph is symmetric about its vertex, the line which goes through x equals to -1 in this case. So if we restrict our domain, then we can ensure that its inverse is a function. So there are two ways we can do it, right? One, what we can do is we can select the right side. That is, when x is greater than or equal to, the x value of the vertex is -1. Or the left side, that is when we consider x less than or equals to -1. In both the cases, it works, since if we do x greater than or equal to -1, we get the upper half. Do you see that? We get this half. And if we do x less than -1, we get the lower half of the graph. Since we get only one half of the graph, it will pass the vertical line test. Perfect, right? Now you knew that the function parabola will not yield inverse as a function since it fails horizontal line test. Perfect. Now if we restrict the domain, then it can give us inverse also as a function, and that is how we do it, right? We just take either side of the vertex. So we restrict the domain of the function to ensure that its inverse is a function, right? So that is the key thing here. Now, it is kind of important for you to note that if I switch the question and if I say determine inverse of the function, instead of writing y equals 2 plus 3, all this, if I give it this part, which is -1 plus minus square root of x minus 2 over 3, you should be in a position to give that as your answer. But how about if I tell you find the inverse of the function where my function is -1 plus square root of x minus 2 over 3. That is, I'm giving you this part of the graph only, the upper half. In that case, remember to write your answer with restricted domain, since this is inverse of the right side of your parabola where x is greater than or equal to -1. Do you understand? If I give you the lower half, which is -1 minus square root of x minus 2 over 6, then inverse of this function is the left part of your parabola. So you have to write this parabola with a restriction that x is less than or equals to -1. Do you understand? That is kind of extremely critical when you're trying to write down inverse of a function, right? So while we are understanding how to find inverse of quadratic function, also understand how to find inverse of radicals or square root functions, okay? That should give you good insight to this type of problems. I hope you're enjoying the process. Thank you and all the best. Now we will take up some examples which will be related to quartic functions, degree 4. Thank you.